Welcome to this explainer. Today, we are seriously leveling up. We're going to transform you from a casual AI user into a systematic AI engineer. You'll be fully capable of configuring, scaling, and securing GitHub Copilot for the enterprise. So we're moving way past the basics of simple code completion, and we're diving straight into true AI governance and workflow standardization.
Looking at our agenda, we have 6 key areas to tackle. 1, the new SDLC baseline. 2, the customization decision matrix. 3, integrating MCP servers. 4, workflows for every role. 5, IDE setup and portability. And 6, defending against AI threats.
Now, before we even configure our first file, we need to establish a crucial operating principle. It comes straight from the engineering handbook. Use the narrowest AI customization mechanism that solves the problem. It's absolutely essential to always default to the simplest, most restrictive tool for both safety and scale. Because giving AI unrestricted access on day one, that's not a strategy. That's just a recipe for a weekend pager alert.
Section 1, the new SDLC baseline.
Let's look at how Copilot completely modernizes your software development lifecycle. It literally accelerates every single phase of your timeline. Think about it. It helps decompose requirements on day 1. It scaffolds repetitive code paths during your day 2 through 10 implementation. It generates boundary test coverage during testing and refactoring. And it even drafts those release notes on day 14 that, let's be honest, nobody actually likes writing. And here's the absolute key takeaway for you. Human accountability for architecture decisions and production-safe remediations, that remains totally non-negotiable.
Section 2, the customization decision matrix. So how do we systematically customize Copilot's behavior to match your team's specific standards? You're going to want to use a strict decision matrix. If you need a stable baseline for repo-wide standards, you use repository instructions. If you've got a repeatable multi-step procedure, you use skills for structured operational guidance. And if you need a specialized role with bounded tools, that's when you deploy custom agents for role clarity and governance. It's all about picking the right tool for the exact job you have. Setting this up from scratch is incredibly straightforward. Step 1, you just create a .github folder right at the repository root. Step 2, add a copilot-instructions.md file for your baseline standards. Step 3, create subfolders for agents, prompts, and skills. And finally, step 4, just populate those with your custom markdown files. This single folder becomes the centralized home for all of your AI configuration assets.
Section 3, integrating MCP servers.
If you're wondering what MCP actually is, it stands for Model Context Protocol. Think of it as a standardized integration that allows AI models to autonomously invoke external tools. It's basically a bridge that securely retrieves context from systems like Jira, Azure, and Docker. So Copilot can autonomously query your local database, check Kubernetes pod statuses, or even read your Confluence specs directly within your IDE. Pretty amazing, right? But, and this is a big but, MCP requires really strict governance. You have to strategically decide when to enable or disable these servers. Enable them for high productivity during planning and debugging? Absolutely. But you must rigorously disable them for air-gapped environments or repositories handling highly sensitive customer data. External autonomous queries in those spaces just introduce way too much risk.
Moving on to Section 4, workflows for every role.
Copilot definitely isn't just a tool for coders anymore. We're empowering entirely different technical roles across the enterprise here. Developers focus on scaffolding, debugging hot paths, and boundary test generation. Architects use it to evaluate coupling, trade-off matrices, and candidate architecture options. QA engineers rely on it to design scenario matrices, boundary tests, and failure path coverage. And your DevOps and platform teams, they can use it to generate CI/CD pipelines, enforce infrastructure as code least privilege policies, and even plan safe rollbacks. And the best part? You can bake these role-specific workflows right into reusable prompt templates, like .prompt.md files, and skills using .skill.md files. This ensures your workflows remain highly consistent and repeatable across the entire team. You're basically standardizing how everyone initiates a task, guaranteeing a consistent output contract every single time. Section 5, IDE setup and portability.
When we look at how this configuration translates across different development environments, VS Code is currently the gold standard. It fully supports Copilot-instructions.md, custom agent pickers, and MCP server integration. Visual Studio 2022 fully supports the instructions, but agent pickers and MCP are version dependent. And JetBrains Writer? It fully supports instructions, but the custom agent picker is still in development, and MCP integration is only partially supported right now. But don't worry, those platforms are rapidly closing the feature gap.
The real beauty here is that all your customization assets live in that .github folder and are committed to Git. This makes them 100% portable and completely IDE neutral. Because they're just standard markdowns stored in version control, any engineer pulling the repo gets the exact same baseline AI behavior, no matter which IDE they prefer to use. Finally, Section 6, Defending Against AI Threats.
This brings us to the most critical layer of our masterclass. What happens when your AI silently reads a poisoned workspace file? I know it sounds like something out of a spy thriller, but we seriously have to ask this. What if a malicious contributor hides hidden instructions in a Markdown file or a Jira ticket that your AI agent is blindly reading for context?
This exact scenario is called indirect prompt injection. It happens when malicious instructions are embedded silently inside files, issues, or web pages that Copilot consumes. It's a critical threat that tricks the AI into silently generating backdoors or weakening your security controls. The attacker literally hijacks the AI's output without ever actually touching your chat prompt. So how do we mitigate this? Human review is your non-negotiable final gate. You must perform line-by-line diff reviews of all files created or modified by agent sessions. Never auto-stage, auto-commit, or auto-push Copilot agent output without human review. You really need to treat Confluence pages, Jira tickets, and external GitHub issues as potentially poisoned. And halt the session immediately if the AI starts generating unexpected workflow files or endpoints. Another massive enterprise risk we have to cover is credential leakage. This is when Copilot reads open workspace files containing secrets, like your .env or appsettings.json files. The AI inadvertently memorizes them and leaks them into code suggestions, PR descriptions, or chat responses. Imagine a production database password popping up in a chat response that an engineer then blindly copy-pastes into Slack. Yeah, really not good. You defend against this by meticulously closing all secret-bearing files, like your .env or .pem files, before starting Copilot chat or agent sessions. Ensure all config files with credentials are listed in your .gitignore, and absolutely enforce strict pre-commit secret scanning hooks using tools like Git Secrets or GitHub Push Protection on every single branch. To stop supply chain attacks on your actual AI instructions, you have to lock things down. Step 1. Enforce branch protection on the main branch, specifically for the .github folder. Step 2. Require mandatory PR reviews from security leads for any AI customization file changes. And Step 3. Set up code owners alerts to immediately notify teams of any unauthorized modifications. So I'll leave you with this question. Are your enterprise's AI tools running wild, or are they operating under secure version-controlled governance? Audit your repositories tomorrow. Set up that .github directory, and make sure you're building software with true AI engineering discipline. Because in the era of autonomous coding, a misconfigured agent isn't just a bug, it's an open door. Thanks for joining me for this explainer, and I'll catch you next time.